Good morning, sir. My name is M. Tirumalesh from CSCG section. My topic name is Explain Adjacent Matrix and Incident Matrix with Example. Subject DMGT. Student name Mancha Tirumaleshu. Roll number 244G1A05DK. Section G section. Batch 2024-2028. Explain adjacent matrix and incident matrix with example. Introduction to graph matrices. Graph theory utilizes matrices to represent relationships between nodes or vertices. Two common matrices are the adjacency matrix and the incident matrix. Understanding this matrix helps in analyzing and solving network problem efficiency. What is an adjacency matrix? An adjacency matrix is the square matrix used to represent a finite graph. Each element in the matrix indicates whether pairs of vertices are adjacent or not. It provides a quick way to determine if two vertices are directly connected. Characteristics of adjacency matrix. For an unidirectional graph, the adjacency matrix is systematic across the diagonals. For a directed graph, the matrix may be asymmetric, showing directionally. The entities are typically 0 or 1, where 1 indicates an edge exists between vertices. Example of an adjacency matrix. Consider a graph with three vertices A, B and C, where A connect to B and C. The adjacent matrix would be A modulus B modulus C, modulus A modulus A modulus B, A B C 0 1 1 1 0 1 1 0 0. This shows the connection between the vertices clearly. What is an incidence matrix? An incidence matrix represents the relationship between vertices and edges in a graph. It is a rectangular matrix where rows correspond to vertices and columns to edges. The entries should whether a vertices is incidence to the edge with specific values indicating directions. Characteristics of incidence matrix. For unidirectional graph, entries are usually 1 if the vertices is indicated to the edge or otherwise. For directional graph, entities can be 1, -1 or 0 to indicate the direction of edges. It provides a detailed view of how vertices connected via edges in the network. Example of an incident matrix. Using the previous graph with vertices A, B, C and edges E1, A minus B, E2, A minus C, the matrix look like modulus E1 modulus E2, A, B, C, 1, 1, 1, 0, 0, 1. The matrix clearly shows which vertices are connected by each edge. Comparing adjacent and incidence matrix. The adjacent matrix emphasizes vertices to vertex connection directly. The incident matrix emphasizes the relations between vertices and edge. Both matrices are usually in different contexts or graphs analyses and algorithms. Applications of the matrices. These are used in network routing, social network analysis and circuit design. This matrix helps in simplifying complex graph problems for computational solutions. Understanding both matrices enhances problem solving skills in graph theory. Thank you.